So here's the do now. We're going to find the coordinates of that point highlighted in yellow, along with the slope between any 2 points along this line. Hit pause so you got your answers, and then you can resume play and check what you got. All right, so this point is x coordinate of 2. We go to the right 2 spaces, and y coordinate of 7. So we got to go up 7. The slope, I chose to use these 2 points down here where MathCat started and where MathCat ended. I just counted squares to get the rise. I went up 4 spaces. And the run, always to the right, was 2 spaces. So I wrote that as a fraction 4/2. Always reduce our fractions. 4 actually does divide evenly by 2, so we got a slope of 2. Today we're going to look at point slope form, which is a new way of writing the equation of a line. Along with that, we have 2 learning targets. One, we'll be able to write the equation in point slope form, either from a graph or just information that we're given, like in words. And the second learning target is we'll be able to create the graph from the equation. So in either case, we're going to need to identify some key information and either put it into or pull it out of this equation. So to recap, we've seen equations of lines before. What we've been using up until now, y equals mx plus b, has a name. It's called slope-intercept form. Math names are, for the most part, very descriptive, and what the name says is what's in the equation. So when we look at y equals mx plus b, that m is the slope and the b is the intercept, and so it's called slope-intercept form. Yeah, that same kind of naming convention also applies to this new form we're going to look at today called point slope form. And so you might imagine in this equation, we're going to find the coordinates of a point, and also we'll find the slope. And so I've got highlighted in green, there are the 2 coordinates of a point. The x coordinate is x1, and in y1 is the other green highlighted point. Slope is in pink. It's going to go right outside those parentheses, and highlighted in yellow these minus signs. So you have to pay attention to these minus signs because it means that the generic base equation before we put any numbers in there already has these minus signs, and that's going to affect the way things look. We remember minus signs, we can also call it a negative, depending on circumstances that may or may not make more sense, but we can think of it as a negative sign, which is just like the reverse card in Uno. So these yellow minus signs in point slope form are going to give our coordinates the opposite appearance of what the actual coordinate values are. I'll show you here with this example. So we're going to write the equation of a line that has a slope of 2 and passes through the point 2, 7. Those are the pieces of information we pulled from the do now. So the slope is going to go into the slope box right here. The x coordinate, that's the 2. The x coordinate is going to go into the x coordinate box, and the 7, which is the y coordinate, is going to go over here into the y coordinate box. Now, if I were to write this equation without any of those boxes, and get y minus 7 equals 2 parentheses x minus 2 close parentheses. So the thing that we notice about this final version of our equation is that in the equation, the part of the equation where we find the x coordinate is inside the parentheses where the letter x is, and it says x minus 2 in those parentheses. But we remember the original coordinate up here is a positive 2, and so it now in the equation has the opposite appearance. It looks like it's a negative. It's not. The negative sign is part of the equation. It's not actually part of the coordinate, which is confusing. That's just the way this equation works. There's a reason for it, which we'll see in a little bit. The same thing has happened with our y coordinate in the equation. We see on the left side of the equal sign y minus 7, the letter y tells us we're looking at the y coordinate, and so that minus 7 has the opposite appearance. It says minus 7 in the equation, but really that came from a positive 7 as the coordinate. Okay, let's look at another example. I think this will be a little bit more enlightening. So I'm going to write the equation of a line with a slope of 2, and that slope is going to drop right into the slope box, and coordinates 4, -3. This 4 Of course, that's the x coordinate. That's going to come over here to the x box, put 4 in here. And then -3, that's my y coordinates, are going to drop a -3 right there. When I clean this equation up and write it without the boxes, one of the other things I'm going to do at the same time is clean up this double negative that I just highlighted in yellow. So we don't want to leave a double negative. I mean, you could, technically it means the same thing, but I don't want to write my final answer with a double negative because it looks weird and confusing. So subtracting a negative number, it's the same thing as adding. So this first part of the equation we'd rewrite as y plus 3 and then equals 2 parentheses x minus 4, close our parentheses, and we'll go ahead and circle that. So we use smiley faces this time. So let's go back and compare our final answer with the original coordinates. So the original x coordinate was +4, and in our equation, inside the parentheses where the x coordinate goes, we see it's the opposite appearance. It says x minus 4. On the other hand, the y at the beginning of the equation says y plus 3, and our original coordinate was a -3, and so it still has the opposite appearance. Whether it was a positive number to begin with in the equation, it appears negative. If it was originally a negative coordinate, or is a negative coordinate, it will appear positive in the equation. And so that's going to be really important when we are given an equation and we have to pull information out of it. We have to remember that. Okay, last example here, I want to take a look at how we can create a graph from an equation. So we're going to graph the equation y plus 2 equals 2/3 parentheses x minus 3. So we're going to have to identify these two pieces of information. We need a point, so that'll be coordinates, and we need the slope. So in order, the point inside the parentheses where that letter x is we're going to find the x coordinate, and the equation will always have the opposite appearance of the actual coordinate. So it says x minus 3, and we know that really the coordinate will be a +3. So it's the x coordinate. The y coordinate is over here by the letter y on the left side of the equation, says y plus 2, which is the opposite appearance of the actual coordinate. I'm going to switch that to a -2 for my coordinate. Slope is this number right in front of the parentheses, so that'll be 2/3. So on my graph, I need to put the point first. That is my starting location. So I'm going to go right 3 and down 2. Here's my starting point. And then from this blue dot, I will use the slope counting squares to find my next point. So I'm going to go up 2 spaces and right 1, 2, 3 spaces to right here. And then I can draw my line, my line drawing tool. Boom, just like that.